So the concentration of a solute in an aqueous solution can be expressed in many different ways. So we could do grams of solute per liter of solution, grams of solute per 1,000 grams of water, moles of solute per 1,000 grams of water, and so on. The most frequently used unit in chemistry is molarity. So molarity is equal to moles over liters. So when you make a solution, you can measure out the mass of the solid that you want to be the solute, and then you add that to what's called a volumetric flask. So this is a very precise measuring tool. It only measures one volume, but it measures that volume to a very high precision. So we would fill it up to the mark with water, and then that would be our solution. So we're going to try to figure out the molarity of sodium sulfate, the molarity of sodium, and the molarity of sulfate. So if we have a Na2SO4 that dissolves in water, so what's going to happen is these ions are going to break apart, and we're going to get 2 sodium ions, and we're going to get 1 sulfate ion. So we get 2 sodium cations and 1 sulfate anion. So if we were to dissolve a mole, we would get 2 moles of sodium for every 1 mole of sulfate. So we want to verify that when we put 10 grams of sodium sulfate in water, that there's this many moles of sodium sulfate, this many moles of sulfate, and this many moles of sodium. So I'm going to start with my 10 grams of sodium sulfate, and all we're doing here is we want to convert our grams of sodium sulfate into moles. So I'm going to need to use the molar mass here of sodium sulfate to do this conversion. So 1 mole of sodium sulfate is going to have a mass of 142.04 grams. So when I solve here, I get this many moles. Now the next one, we want just moles of sulfate. So I'm going to start this out pretty similar, where I'm going to take my 10 grams of sodium sulfate and convert it into moles. But this will give me moles of sodium sulfate, and I'm looking for just moles of sulfate. So I'm going to need to do another conversion factor here, where we convert the moles of Na2SO4 into moles of just SO4. So from our previous question, we saw that this mole ratio is 1:1, which is why my answer is the same as my previous answer. But now my units are just moles of sulfate. The last one here is sodium. So I'm going to start off pretty much the same. I need to take that grams of sodium sulfate and convert that into moles. So I'll divide by the molar mass to do that. Now we want our answer to be in moles of sodium. So I'm going to convert my moles of sodium sulfate into just moles of sodium. So that mole ratio is 2:1. There's 2 sodiums for every 1 sodium sulfate. So that's why our answer is double what we got for the previous 2 questions, because of that mole ratio. So now that we know the moles of each of these compounds, if we divide this by the volume in liters, we'll get the molarity. Same thing here. And here, remember, our answer was double. So I got to divide each of these by my liters. We were given 250 milliliters. So we're just going to convert this from milliliter to liter by dividing by 1,000. So I need to divide all of these by this value. So we're going to go ahead and do this math here. So the molarity that I get here is this. The molarity of the sulfate is going to be the same. And my molarity of sodium is going to be double that. So we have the concentration for these three solutions now. Or rather, this is the same solution, but we have the concentration of the ions as well as the original solute. Okay, so we have 1 liter of 0.5 molar NaCl and 1 liter of 0.3 molar sodium sulfate. Which one is more concentrated with respect to sodium? So if you take sodium chloride and add it to water, it's going to break apart into sodium ion and chloride ion. And that ratio is 1 to 1. So if this is 0.50 molar, then this is 0.50 molar, and this is 0.50 molar because of the 1 to 1 stoichiometry. Whenever we add sodium sulfate into water, we get 2 sodiums and 1 sulfate. So if this concentration is 0.30, then the concentration of sodium is double that, and the concentration of sulfate is the same. So which is more concentrated with respect to sodium ions? This guy. Okay, so if we wanted to make 50 milliliters of a 1 molar solution of sodium carbonate, our equation for molarity is moles per liter. And volume needs to be in liters, not milliliters. So using the molarity equation, solve for the moles of sodium carbonate required for 50 milliliters of a 1 molar solution. So first, I'm going to need to take that 50 milliliters and make sure that is in liters. So I'm going to divide by 1,000 to do that. Now my molarity equation is molarity equals moles per liter. We know the molarity of the solution that we want is 1.0 molar, and we know that we want to make this many liters of that solution, so we can solve for the moles required to do that. So this gives me 0.050 moles of sodium carbonate. Now, sodium carbonate is a solid, so we would want to weigh this using a scale. But there's no scale that measures in moles because every compound has a different molar mass. So I'm going to just change my moles of sodium carbonate into grams of sodium carbonate. So this is just a molar mass conversion here. So 1 mole of sodium carbonate has a molar mass of 105.99 grams. So I'm going to go ahead and do this math here. And this gives me 5.3 grams of sodium carbonate. So I would take that 5.3 grams of sodium carbonate, measure that out on a scale, add it to a 50 milliliter volumetric flask, and then fill it up to the line. So what are some measurements that we need to use to make this solution? So we've got to measure out that 5.3 grams of my solid, And we also have to measure that 50 milliliters of solution of water. So what if our scale measures 5.2 grams? So that means that our concentration is going to be too low. What if we get a little more than 5.3 grams? Well, that means that our concentration is going to be too high. What about the 50 milliliters? What if we accidentally measure 49.8? Well, now I don't have as much water, which means that my concentration is going to be too high. What if we go a little bit past the mark? Well, now there's too much water, so my concentration will be too low. Question 9 is asking which one has more moles of sodium carbonate. So we've got two solutions here. So remember that our molarity equation is moles over liters. So for my first solution, I have 1.9 molar, and I have 0.15 liters of it. So I can solve for moles. And in my other one, I have 1.0 molar, and this time we have 1/4 of a liter. So we can go ahead and solve for the number of moles that are present in both of these. So this one is going to be 0.25 moles, and this one is going to be 1.9 times 0.15, which gives us 28.5. So which has more moles? It's the first one here.